Hi everyone, welcome to my channel. So today I'm going to talk about Argand diagram. So what is an Argand diagram? So basically Argand diagram is a Cartesian plan for complex number. So what we need to know is the complex number have a general form with x plus yi. And when we draw a Argand diagram, the axis is not x-axis, is real axis and imaginary axis. So the x is that the real part of the complex number and the y is that the imaginary part of that complex number. So let's see some example. So plot each of the complex number in the Argand diagram. So for example, 3 plus 4i. So the real part is 3. So in the real axis, we plot a 3. And for imaginary part is 4. So in the imaginary axis, we plot 4. So this is the point that represents complex number 3 plus 4i. And for the next thing, negative 8i, negative 6. So in this example, so negative 8 is the imaginary part and negative 6 is the real part. So real part is negative 6 and imaginary part is negative 8. So this is the point that represents negative 8i, negative 6, or we can write it as negative 6, negative 8i. And for the last example, which is the complex number is just include 5 for the real part only, which means this not they not have the imaginary part. So imaginary part is 0 and the real part is 5. So this is the point that represents the complex number which have 5 which with the real part. And the next thing we need to talk about is the modulus. So basically the modulus is the length between the origin and the point. So for example, we have a complex number x plus yi. So we can connect it with the origin and the length of this line is we call modulus. So the general equation of the modulus is square root x squared plus y squared. This comes from the Pythagoras theorem. And instead we write modulus, we also can use the symbol like this. So the modulus x plus yi is equal to square root x squared plus y squared. So we go to some example. So for the first 3 plus 4i. So the modulus of 3 plus 4i is equal to square root x squared, which is real part square, which is 3 squared, plus y squared. Y is the imaginary part, which is 4 squared, is equal to square root 25 is equal to 5. So that means if they have a complex number, that the point represents 3 plus 4i, the length between origin and that point is 5 unit length. So for the next, negative 8i, negative 6. So the modulus of the complex number is square root x, the real part is negative 6, and plus imaginary part, which is negative x squared, which is square root 100, 10 unit. So for the last, so modulus 5 is equal to square root, real part is 5, and imaginary part is 0, so which is equal to 25, which is 5 unit. Now I will talk about argument. So what is an argument? So graphically, I can draw the argument for a complex number. For example, there have a complex number which is x plus yi. So the length of the line that connected origin and that complex number is what we call modulus, right? So that is the thing that we learned before. And the line and the angle between the line and the x positive axis, which is the real positive axis, the angle is what we call the arguments. So the arguments of a complex number have a general equation. Its argument is equal to arctangent imaginary part divided by real part. So next, we see some example. So for the first example, so we want to find the argument. So 2 plus 2i. So we find the x and y for this complex number first. So the x is 2 and the y is 2. So this is x, this is y. So the argument for 2 plus 2i is equal to arctangent 2 divided by 2, which is arctangent 1. So which is pi over 4. So this means if they have a complex number 2 plus 2i, so the angle between the line and the real positive axis will be pi over 4. So let us proceed to the next example. So the next example is negative 5 square root 3 plus 5i. So the argument for this complex number is equal to arctangent 5 divided by negative 5 square root 3, which is equal to arctangent 1 over square root 3 with negative sign. So which is negative pi over 6. So before we think about the arguments, so we can use an Argand diagram to make it simpler. So real part and imaginary part. So for negative 5 square root 3 plus 5i, the point will be in the quadrant 2, second quadrant, which is something like that. Okay, with the negative real part and positive imaginary part. So when we use the arctangent, we will get the reference angle, negative pi over 6. But the real thing is argument is the angle between the line and positive x-axis. So we need to find this with is our arguments. So the argument actually is pi minus pi over 6, which is 5 over 6 pi. So let's see the third example. Let me clear this one first. So the third example is -10 square root 3. So argument of this complex number is equal to -10 square root I, sorry, arctangent -10 square root 3 divided by -10, which equal to arctangent square root 3. So which is pi over 3. So the same thing is, we can realize that this complex number is in quadrant 4. -10 -10 square root 3. So what we get is actually the reference angle. So this is pi over 3. So actually the argument is 2 pi minus pi over 3, or we can just write negative pi over 3 directly. So this is what we call argument. So we can go through the example 4 directly. So find the locus of the point z that satisfy each of the condition below. So for the first question, so the condition is modulus z minus 3i less than n or equal to 4. So before we do anything, the first thing we need to do is let z equal to x plus yi, and we substitute the equation. So x plus yi minus 3i is less than or equal to 4, which means x plus y minus 3i modulus is less than or equal to 4. So remember the equation of the modulus is x squared plus y squared. So the real part square plus the imaginary part, which is y minus 3 square, is less than or equal to 4. So we can get x squared plus y minus 3 square less than or equal to 4 square. So our locus is x, y such that x squared plus y minus 3 square less than or equal to 4 square. So with this equation, we can sketch the locus of this condition. So this equation is a circle with, so this equation is the circle with radius 4 and the center 0, 3. So and we just plot the point, plot the center which is 0, 3, and draw the curve. This imaginary part. So our locus is this area. So this is the first type of the locus, which is the locus is a region. So we go through the second question, which is 4z squared plus 4 conjugate z squared plus 24 modulus z squared equal to 80. So the first step is always the same. Let z equal to x plus yi. So the conjugate z is equal to x minus yi. So we substitute the z and conjugate z and the modulus z into the equation. 4x plus yi square plus 4x minus yi square plus 24. So remember the formula of the modulus, x square plus y square. So okay, square is equal to 80. So let me expand the equation. 4x plus yi square is equal to x square plus 2xyi minus y square, and plus 4x square plus minus x square minus 2xyi minus y square, and plus 24 times x square plus y square equal to 80. So the one thing you need to remember is I square equal to negative I. So I square is equal to y square times I square, which is negative y square. So we simplify the equation. So after the simplification, so we'll get 32x square plus 16y square equal to 80. And we divide by 16. So we'll get the equation 2x square plus y equal to 5. So the equation of our locus is x and y such that 2x square plus y equal to 5. So we also can draw this equation into a curve, so which is an ellipse. So the y-intercept is square root plus minus square root 5, and x-intercept is plus minus square root 2.5. So since the equation need to equal to 5, so we no need to shape the region because the equation is a curve, not a region. So this is the second type of locus. This locus is a curve. So next, so you see that this simple question, which is argument of a complex number is equal to pi over 3. So remember that the argument means the angle between the line and positive x-axis. So that means there exists a line. The argument is equal to pi over 3. So this line is satisfied this condition. So the locus is a line. So next question. So argument of a complex number is between pi over 4 and 3 pi over 4. The argument is between pi over 4 and 3 pi over 4. we draw a Argand diagram. So the line that has an argument with pi over 4 is here, and the line with an argument with 3 pi over 4 is here. So between these two lines is this shaded region. So the locus is a region for this condition. And we go to the last question. Z plus modulus conjugate Z equal to 18 plus 12. Z plus modulus of conjugate Z is equal to 18 plus 12i. So let Z equal to x plus yi. So the conjugate Z is equal to zx minus yi. So substitute x plus yi plus square root x squared plus negative y squared equal to 18 plus 12i. So x plus x squared plus y squared is plus yi is equal to 18 plus 12i. So we need to do a comparison with the real part and the imaginary part. So we can know that from the imaginary part, we can know that y equal to 12 and x plus square root x squared plus y squared equal to 18. So square root x squared plus 12 squared equal to 18 minus x. X squared plus 144 is equal to 18 minus x squared, which is 18 squared 324 minus 36x plus x squared. So 36x equal to 324 minus 144. So which is 180. So x equal to 180 divided by 36, which is 5. So now we can form the z, which is x plus yi, which is 5 plus 12i. So this is the last type of a locus, which is the locus is a point. So that's all for today's part for the Argand diagram. Thank you.